Hi everyone. Looking to have a better understanding of complex numbers and some of their common properties? Well, you've come to the right place. Stick around and I will go through some of the basics and increase the complexity to give you a more thorough idea how complex numbers are used in real life. So, why are complex numbers important? Well, complex numbers have a variety of applications, one of them being electrical power, control systems, image processing, communications, quantum physics, electromagnetic waves, amongst others. So, what is a complex number? A complex number is a number that has both a real part and an imaginary part. One such example is 1 plus 3i, where 1 is the real part of the complex number and 3i is the imaginary part of the complex number. Having said that, so what is I? I is the square root of -1, which can also be written as such. So what are some of the properties of I? Well, I squared is equal to -1. I cubed is equal to minus I, and I to the fourth is equal to 1. Following the properties mentioned above, I will solve the following. So what is I to the 7th? It's I to the 4th times I cubed. And we know that I to the 4th is equal to 1. And we know that I cubed is equal to -I. So this would be equal to -I. What would be I to the 12th? I to the 12th is I to the 4th times I to the 4th times I to the 4th, or it can be I to the 4th cubed, and we know that I to the 4th is 1, so it'd be 1 cubed, which equals to 1. And what would I to the 15th be? Well, it would be I to the 12th times I cubed. We know that I to the 12th is 1, as was demonstrated before, and we know that I cubed is equal to -I. And so I to the 15th is equal to -I. So this just shows the power function of imaginary numbers. Now we will proceed with a demonstration of how to plot and perform some basic math functions, which include addition, subtraction, multiplication, and division using complex numbers. For this demonstration, we will start with addition, then subtraction, then multiplication, and finally division. So let's name some points just so we have an idea of the real and complex plane, how they work. So we have A, which is A1 plus 1i, and B equals 2 plus 2i. So let's draw out A. A is right here, since this is 1, and this is 1. And B is right here. So A and B. So let's say we have a point C, which is A plus B. So that equals 1 plus 1i plus 2 plus 2i. And so we add the real part and we add the imaginary part. And that equals 3 plus 3i. So C would be right here. Now let's say we have a point D, which is A minus B. So that's 1 plus 1i minus 2 plus 2i. And that equals 1 minus 2 plus 1 minus 2i. And that's equal to minus 1, minus 1i. So we have point D is right here. Since this is minus 1 and this is minus 1, this would be our point D. So now we have a point E. Let's say that's A times B. So we have 1 plus 1i times 2 plus 2i. And so here we have 2 plus 2i plus 2i plus 2i squared. And so we have 2 plus 4i plus 2 times minus 1, since we know that I squared equals minus 1. And so that's equal to 4i, since 2 and minus 2 go away. So E would be right here. Now division. Let's say we have a point F, and that's A divided by B. So that equals 1 plus I divided by 2 plus 2i. And so the first thing we do here with division is that we have to make sure our number never has an imaginary number in the denominator. And so in this case, we're going to multiply it by 1. And so this is how this works out. So we do 2 minus 2i over 2 minus 2i. That equals 2 minus 2i plus 2i minus 2 times I squared. And the denominator is 4 minus 4i plus 4i minus 4i squared. So moving that would be 2. That equals 1/2. So if we were to plot this, it would just simply be right here. So that concludes our demonstration for both addition, subtraction, multiplication, and division. So after showing how to perform the basic math functions using complex numbers, you might be wondering what software or tool can I use to check and see if my calculations are correct. Simple. Matlab can be used for this purpose. Having said that, we will proceed to make a demonstration in Matlab and check our answers that were done with the previous demonstration. So using Matlab, we'll check our answers that we had in our first demonstration. So we'll create A, which was 1 plus I. We'll also create B, which is 2 plus 2 times I. And so we'll do the addition, subtraction, multiplication, and division. So just to check our answers and make sure that what we got in our previous demonstration is correct. So we'll start with addition, so A plus B. And just like our demonstration, it's 3 plus 3i. So now the subtraction. Same answer, minus 1 minus I. Now multiplication. We get 4i. And now the division. We get 1/2. So this just shows that the previous demonstration was correct. And now let's plot these. So let's say we want to plot 3 plus 3i, which was the result from our addition. Also, let's plot minus 1 minus I, which was our result from our subtraction. Also 4 times I, which was our result from the multiplication. And 1/2, which was our result from the division. So and let's test to see if that got it. So we have 3 plus 3i minus 1 minus I, 0 plus 4i, and 1/2 plus 0i. So now let's plot these and see how they look. So just like in our demonstration, we have all the same plots. So we have our origin, which is 0, 0 right here. We have our division, which was 1/2. We have our multiplication result, which is 0, 4i right here. We have our subtraction result, which would be minus 1 minus I, which would be right here. And we have our addition, which would be 3 plus 3i. So that just comes to show how you can plot and check your answers when using complex numbers in Matlab. Well, hope this video was a good introduction to complex numbers. Please do not forget to subscribe. I will provide a link to other pertinent videos at the end of this video.